Moving forward, how many grams of potassium permanganate are required to prepare 2 quarts? I got a lot of students asking me, Miss L, how much is 2 quarts? You got your conversion factor, right? Okay. Of a 1:750 ml of potassium permanganate. So 1 gallon is 3,785 ml. That's ingrained in here. I cannot forget that. So even if I don't know, I've forgotten the quarts, I'll just divide this by 4 and I can get my milliliters.
I got 946.
946. That's why in your conversion, in your charts, they rounded up to a 1 liter. 946.
Oh, okay.
But this is the exact number for a gallon, just so you know. Okay? So, if 1 quart is 1 liter, okay, by the way, there are 2 pints in a quart, just so you know. Okay? That's why I gave you the other dosage calculation sheet. Minims, fluid grams, okay, fluid ounce, pint, quart, okay, gallon. Okay. So, going back to the problem, you need 2 quarts. So, if you, in your cheat sheet, 1 liter is 1 quart, you said? So, it will be how many liters? 2 liters is 2 quarts. Okay, that was a given, right? Okay, so you have a 1:750. What are the invisible units here?
Gram and liter, milliliter.
As to
X grams.
X grams is to
2,000 milliliters.
2,000 milliliters because you have 2 liters, right? Okay, you want to make it apples to apples. So 2,000 divided by 750 is in grams.
2.67.
2.67 grams. But was that the question in grams? Were your options in grams? Yes, your options were in grams. So, what's the best answer? Whatever is closest to that, 2.67 grams. Your option is 2.56 grams. That's the closest. So, you choose letter C. Okay? My guess, this 2.56 is based on my 3785.
That's what I got to, 2.522636. Using that one.
Yeah. Pharmacist, meaning. Okay? Who formulated a question. Okay? Next. 3 is just conversion. Number 4. Okay? What method? It already stated it in there. Okay. This is just ratio and proportion for you to, for whoever made this quiz or practice problem to determine whether you understand percentages and proportions, okay? This number 4 is alligation, and I'll do it, and then it's your turn, okay? Okay. How many grams of 12% yellow mercuric oxide? Miss L, I don't have an idea what mercuric oxide is, okay? Because you didn't do physical chemistry. It's fine, okay? You'll use any other drug, any other powder, any other active ingredient in there, as long as you know how to do the math. Because this is a math class, the questions will be just based on math. So you don't have to worry about what specific drug that is, okay? How many grams of 12% yellow mercuric oxide must be added to 30 grams of 1% yellow mercuric oxide ointment to prepare 5% ointment? The word is ointment, so I know that this is grams over grams. Why? What's your ointment? Semi-solid dosage form. So I know that my numerator is in grams and my denominator is in grams, okay? What are the numbers I can play with? I got a higher percentage, which is 12%, right? I got a 1%, which is a lower percentage, and I have a 5%, which is what we want to figure out. I would go back to the problem and read the problem again. Why? Because I want to know what's really being asked of me. Sometimes it's only this part, sometimes it's this part, sometimes it's this part. And this is how I do alligation. Higher number, lower number, the middle strength. Higher strength, lower strength, the middle strength. Okay? Next step. 12% minus 5% absolute. There's no positive or negative. Absolute always positive. 12 minus 5 is? I will write 7 in the word parts. 5 minus 1, absolute. I will write 4 parts. I will add this to 7 plus 4 is 11 parts. And I would do the word total here. This is how I do it. Okay. I'm going back to the problem because I didn't understand it the first time I read it. Okay. How many grams of 12% yellow mercuric oxide must be added to 30 grams? I know that 7 parts is 30 grams now of yellow because it's on 1% mercuric oxide to prepare a 5% ointment. So this will be my X in grams. Can I work with these numbers? Definitely. Now I can work with these numbers. And what do? Simple ratio and proportion. If 30 grams is equivalent to 7 parts, X grams would be 4 parts would be X grams. So 30 times 4, help me out please. 120 divided by 7 is?
17.14.
Huh?
120 divided by 7.
120 divided by 7 is?
17.14.
17.14 grams. And that is for this one. Okay? If I want to know the total, I can simply add 17.14 plus 30. Or if this is given, now I subtract this total from whatever other number is given. So, since the question was only for which one? 12%, my answer would be 17.4 grams. Okay, is there an option for 17.1 right there? So the answer for number 4 is B. Who understood it? No? I want to see. No? A little bit?
A little bit, but it's still.
One more. I'll find another allegation here. Number 6 is easy. Did I ask you to do number 6? No? What's the next number I asked you to do?
7, 8, 9, and 10.
7, 8, 9, and 10. 7 is not even an allegation. This is simple. If there are 30 grams of dextrose in 500 ml, what percent solution will it be? So easy. 30 grams divided by 500 ml. What do? Times 100, then you get your percentage. What's the answer here?
6%.
6%. The answer is letter D. Got that? Who got that? Okay. Number 8. Another one. We've been doing this last night on the board. How many grams of dextrose are in a 750 ml D10W? We got your 10 grams, right? Over 100 ml right off the bat because that's your given. Okay? And then what's next? Your X grams is 2. What's the given? 750? Oh, what number are we? Yeah. Number 8.
Sorry.
750 ml. So what's the answer on this one?
75 grams.
75 grams of dextrose. Look at your options. 750 grams, 75 grams, 10 grams, 7.5 grams. It's really confusing and tricky. So 75 grams is the answer, but what if the question was how many milligrams of dextrose is needed? What if the question is that? What's the answer?
It would be 75,000.
It will be 75,000 milligrams. Is that clear? No matter what you do, as long as it can be converted to another unit of measure, you should be able to do it. Okay? This is easy. They usually don't give you the normal saline percentage, just so you know. You should know it. Number 9, how many grams of sodium chloride are in 500 ml of normal saline? We know that normal saline is 0.9 grams for every ml because normal saline is 0.9%. What's your proportion on the other side? X grams is to 500 ml. Cross multiply. 500 times 0.9 divided by 100 is? 4.5 grams. You got that one? I'll find another allegation. Do we have another allegation or dilution? Number 24. Who was able to answer number 24? This is easy. Okay, number 32. Last allegation that I'm going to do. Number 32, and then you guys go on the board, okay? I'll sit down and see how you guys do it, because there might be other ways of doing it, which we did this morning too, okay? Some students are more comfortable with dimensional analysis, like really long dimensional analysis. Okay, you are asked to make 150 ml of a 3% sodium chloride solution using 5% sodium chloride stock solution. How much of it do you use? Okay, here's another tip. This is a dilution question. So you may use C1V1 equals C2V2, which is way easier for me. Ms. Al, can I use alligation for dilution? Yes, as long as you know that water is 0%.
Oh. I couldn't get that because I couldn't figure out what the other one was.
You can use alligation as long as you know that the other percentage needed is water, and water is always 0%. It doesn't have strength. Okay? We'll try to do it both ways. But I do this right away. Once I see that it's a dilution problem, I do the C1V1 equals C2V2. So number 32. You are asked to make 150 ml of 3% sodium chloride using 5% sodium chloride stock solution and water. How much of each do you use? What's your C1?
3%.
3%.
Using 5% sodium chloride stock solution. So 5% first. Remember the higher first to make it. Okay. How much of each do you use? Do you really can use C1V1 equals C2V2? Or is it better to use alligation at this point? Okay? 5% is what you need. The question was, you use 5% sodium chloride stock solution. How much of each do you use? You are asked to make, your to make goes on the right side now, okay? So 3% of how much?
150 milliliters.
150 ml. 3 times 150, Shannon, divided by 5 is 53 ml. Okay, but that wasn't the question, right? Is that right? 150 times 3 divided by 5 is, are you sure it's 53?
I got 90.
Doesn't seem right to me, just looking at it. Answer, 90 ml.
Yeah.
Okay,
Yes.
which means 90 ml of what? Of the 5% is what you need, right? How do I do this shortcut? You have a total of 150 ml. 150, since I've already gotten the 5% to be 90 ml, my 5% contains, or I have to use 90 ml of the 5%, okay? I have a given total volume of solution at the end, so what do I do as a shortcut? 150 minus 90 would be 60 ml. So I need 90 ml of the 5% solution and 60 ml of the 3% solution. Is that clear?
Yes.
So still I want to try the ratio proportion. Let's do it. Okay. What do you need? The 3 at the middle, right? You're given the 5. You have to add 0. 5 minus 3 is 2. I'll write the parts right away. 3 minus 0 is 3. I'll write the parts right away. And then I got total 5 parts. Where do I put the 150? Right here. Okay? What do I do next? This is the second way to do it using alligation, but you have to know that water is 0%. I already got a proportion right here going on, right? If 5 parts is equivalent to 150 ml, then I can choose whatever. 3 parts is equivalent to X ml. 150 times 3 divided by 5 is 90 ml. So I know that this is 90 ml. You can compute for this as well, or you can simply 150 minus 90 equals 60 ml. Clear?
Yeah,
Who understood?
I do now.
Doesn't matter what questions thrown at you, as long as you know how to plug them in and you understand which is which. Oh, does the 150 correspond to the 3%? Or does it correspond to the initial concentration? Okay, here's my tip. On the C1, V1 equals C2, V2 on the dilution. To make is your total volume, which means your V2. To make is your C2, final concentration. Okay? When you hear the word stock solution, that's your original concentration, so that's your C1. From, okay, that's your V1. Okay? Any questions? Nuh-uh. No, it's your turn.